Welcome back, everybody. We, of course, have been talking about the scientific method, and hopefully through your readings and the videos and some of the activities that we've had for you, it's making some sense. And of course, there's a lot of terminology related. And so I just wanted to walk us through what independent, dependent variables are, and talk a little bit about control groups or constants. Okay, so if you are the one that is manipulating, or the variable that you are manipulating is the experimenter, that's your independent variable, right? That's the one you're controlling. What you're hoping to have an impact on is your dependent variable. So we'll go through some examples, and then, as I said, we'll talk about controls. There's that if you wanted to check your work. I'm just going to pause on some of these spots where you can visually check your work. And then, of course, you can pause on it while you're watching the video if you want to use it as a key. Otherwise, we'll move on. So we had you do some independent and dependent variable practice. You had some little squares here, and you moved them around so that they were in a relationship with each other. And this is probably how you ended up with it, but a couple examples of you start with a question, right? You've made an observation, you have a problem, you state it as a question, and then, of course, you make a hypothesis, and that hypothesis is going to have an independent and dependent variable. So just one example here at the bottom, does being tardy impact test scores? Okay, well, we can test that. We can measure something there. Test score is probably what we're measuring. The time a student arrives to class, we can manipulate that, right? We can change that and see if there is, in fact, a connection, a cause and effect relationship there. Okay, so we had you go through some writing a strong hypothesis practice type questions here. So if you look, you can see how does the length of light affect the growth of a plant, right? We have a problem, and we want to be able to run a experiment to answer our question. And so what would be our independent variable here? What could we as experimenters manipulate? In this case, it would be the amount of light, or the length of light. The dependent variable, right, something we could measure, would be the height of the plant, maybe the weight, or the mass, but that'd be more difficult. So what forms our because statement? In other words, a hypothesis is an educated guess. What makes it educated? Well, it has to do with your own background. What are you educated in that allowed you to make this hypothesis, to make this prediction? Well, you know that plants need light to grow. So that sort of is your related to your because statement. So here you go. If the length of light increases, then the plant will grow taller, right? You're independent. If your independent variable, then your dependent variable, and your because, well, we know something about plants, right? We can link it to that. Okay, so we had you do several examples, and I'm not going to go through each of them, but I'll move through it here so you can check your work. Maybe I need to get some background music. All right, what effect does high temperature have on radish germination? So germination, maybe we know, a plant starting from a seed and turning into an actual plant, right? So let's just take a look at this one. We as researchers can manipulate the temperature, right? We can heat up the ground or cool it down, and we can measure the growth of a radish, again, by how big it gets, how many of the seeds actually germinate. There you go. Music and student test scores. Okay, sort of related topics to running a good experiment, very highly related, would be control groups versus experimental groups. And so oftentimes you'll take sort of populations of, potentially people or organisms, right? And you want to see an impact of a test on one group versus another group, right? So you need a group to compare to. That's your control group. You want to keep as many things constant in that group as compared to your other group. So your experimental group is the one in which the independent variable will be applied, right? And that gives you a chance then to compare these two groups. So if you take a look here, how does the amount of water affect the sprouting of seeds? Well, we can measure that, right? Because we can impact the amount of water. We can choose the type of seeds. So if you look on the left here, our independent variable, amount of water, dependent variable, how many seeds come up, right? We can measure that. Well, 9 out of 10 came up in the case where water was added. 0 out of 10 came up where no water was added in our control group. But everything else was the same in that control group, right? We had the seeds, the same soil, the same pot. Everything but the water was applied to that pot. All right, there you go. So when we're measuring, right, because we talk about measurement a lot in science and certainly in the scientific method while we're running tests, there's a couple different types of data we can collect. There's the 2 Qs, right? Most of us probably have heard of this or aware of it, but we had you do a little practice. So if it's quantitative, it has numbers, units. Qualitative, right, is more descriptive. So some examples here, right? If you drag these in, you can see the quantitative has, again, both a number and a unit, whereas qualitative is more descriptive, adjectives. Okay, so now you've run your tests, right? You made your hypothesis, you set up an experiment, you've run your tests, you have some data now. What do you do with it, right? What do we do with this data? Well, of course, we need to organize it. And how do we do that? Well, we put it into data tables. So what are the things you need to be considering when you're going to put a data table together so that it's efficient, so you can actually analyze the data in a way that makes sense, or it allows you to plug it into probably a graph, which will allow you to analyze that data even better. So you can see there some of the things that you need to consider. Oops, sorry. So data collection, the data table allows you to organize information, right? You might have jotted a bunch of numbers down on your paper, but if you don't have any organization to them, what do they mean? How are they related to each other, right? So it creates a place for you to show the relationship between your variables, right, with columns and rows, right, the data table. And then, of course, you move into graphing, which is what we're going to be doing next. But here you can again, check your work. And then our final work we had you do is to take a look at a scenario and read this, right? There's a lot of data there, a lot of information, and it's hard to work with that information in this format. So how could we take that information and put it in a way that effectively illustrates it for us so we can actually analyze it, we can actually make some sense of it. And there's probably more than one way to do it. But if you think about the things you need to pull out, right, your controls and your independent variables and your dependent variable, right, if you can find those things, right, in the scenario and you pull those out, right, now you can think about how can I create a tool that will allow me to gather information, data in an efficient, effective way. So again, here's a possible way, right? You always want a title: effectiveness of oil on pop right popcorn. over here, amounts of oil, right? And then in your trials, how many popped, right? How many kernels, if you tried to pop kernels, how many popped in each of your different trials with the different volumes. Okay, we'll see you next time.